Alright guys, we are moving on to lesson 3.1b. We're still going to be working with fractions, these evil little creatures, but we're going to be exposing them for the evil little things that they are and turning them into decimals, which is nice because decimals are a lot easier to work with than fractions. I mean, they look better, they're just not as complicated. So if we can turn them to decimals, that makes life a little bit easier. Today we're going to talk about fractions that make repeating decimals. Okay, some fractions that we divide, like 1/3, when we divide this out, some of these fractions change to decimals and go on and on forever. Okay, this is a sneaky way that fractions try and make you think that you can't divide them and get an answer. Alright, see how sneaky they are? They're always trying to pull something, these fractions. Alright, let's take a look at 1/3. Watch what happens here. So I have 1/3. I'm going to divide it, so let's just flip this thing to the right. So 1 is going to be on the inside. There's our fraction bar. There's our 3. Now watch what happens when we start dividing this, okay? So we're going to add our secret weapon, the 0, because 3 will not go into 1 just like we did in the last video. Our decimal point is going to go right there. Everything is still the same. Let's take 3 into 10 now. That's going to be 3 times. 3 times 3 is 9. I'm going to take away 9. That's going to give me 1. Now remember, we don't want a remainder, so we have to keep dividing until we get no remainder. So I have to blast it with another secret weapon, the 0, drop it down. 3 goes into 10 3 times. Okay, so 3 times 3 is 9. I'm trying to not get a remainder. 10 minus 9 is 1. So I have a remainder. I have to blast it with another 0 here to try and get rid of this remainder. And look what's happening. Do you guys see the pattern here? Every time I get a remainder, it's always a 1, and I add another 0, I take away 9, and I get another 1. Add another 0, I would take away 9 right here. That would go in there 3 times, and it would just keep going and going. This is a repeating decimal because no matter how many zeros I add onto this, it's always going to be 10 minus 9 with a remainder of 1. It's never going to stop. Never. Okay? So, we have a way to work around this. This is called a repeating decimal. So we don't, once we find the pattern that it's always going to be 3's, you don't have to keep dividing anymore. Don't do it. It'll make yourself go crazy. Then they'll have to send you to a special place. Alright? So, we are going to stop dividing here, and our answer is going to be 0.3. But since the 3 keeps on going, we put this bar up here. This is a repeating bar. That lets everybody know who speaks the math language that this is 0.3 repeating, that it's always going to be 3's. Okay? So isn't that kind of nice? We don't have to keep dividing anymore. We can stop right there. Alright? Sneaky fractions. Those things are so sneaky. Let's take a look at a few more examples. Let me show you some more repeaters, and we'll see what we get. Alright, a couple more repeaters here. I'm going to work these out with you guys. This one we have 5, 6. It's going to be 5 divided by 6. So, 5 divided by 6. Alright, and let's see what happens. I'm making that line longer because I know I'm going to have to add some zeros to it. 6 does not go into 5. Put a 0 there. Our decimal point is going to go right in between the number and where we put the 0. 6 goes into 50 8 times. Okay, that's 48. Alright, subtract those two. That's going to give me 2. I have a remainder. Hit it with a 0. Alright, now we have 6 into 20. That's going to go in there 3 times. 6 times 3, 18. Take away 18. Subtract that, I get 2. Still have a remainder. Gonna hit it with another 0. Drop that down. 6 goes into 20. 3 times. 6 times 3 is 18. And I have another 2 again, which means if I added a 0, I'm gonna get another 20, just like I got before. So this this decimal is gonna keep going on forever and ever. It's always gonna be 3. It started off with an 8, it looked okay, and then we got a 3, and then it just kept being 3's, and it's going to keep on being 3's if we kept going and going. So we're going to stop right there. This is a repeating decimal. Once we find that pattern, we stop, and our answer is 0.83. And watch where I put the repeating bar on this one. The repeating bar is just going to go over the 3. Okay, because the 8 doesn't repeat. The 8 is just there one time. It's the 3 that's repeating. So you got to make sure you just put it on the 3 to show that the 3 is going to be repeating. Alright, take a look at 7 over 11. Watch what happens when we try this one. 7 divided by 11. Let's change that into a decimal. Okay, 7 divided by 11. I got it set up right. 11 will not go into 7. Throw in a 0 right there. Alright, get your decimal point. 11 goes into 76 times. That's going to be 66. 11 times 6 is 66. Subtract that. That's going to give me 4. I got a remainder, so hit it with another 0. Bring that down. 11 into 40. That's going to go in there 3 times. Let me extend this out a little bit. 11 times 3, 33. Subtract that. Gives me 7. Still have a remainder. Blast it with a 0. Trying to get rid of these remainders. 11 into 70. 6 times. 11 times 6, 66. Okay, take that away. I'm left with a 4 after I subtract. Still got a remainder. Hit it with a 0. 11 into 40, 3 times. 11 times 3, 33. And it's another 7. Take a look what's going on here. Alright, this is a repeating decimal where we have 2 numbers repeating, 6 and 3, 6 and 3. See, it's always going to be 40 and then 70 and then 40, and then if I put a 0 there, 70 and then 40. So this has 2 numbers that are repeating. See how sneaky that is? Okay, so here's how we would identify this repeating fraction. It is 0.63, and our line is going to go over top of the 6 and the 3, the repeating bar, to show that it's always going to be 63, 63, 63. Okay, that's our pattern. Alright, I have a couple of fractions for you guys to try. Take a look at the try this problems, work those out, see how you do, and then check back in and let's check your answers.